This is a brief demonstration of first the wired and then the wireless data LCD display panel that can be used for any type of underwater propulsion system. The unit consists of a number of parts. This is a waterproof housing that contains all the processing electronics, the motor interface, the speed controller, processing electronics and sensors. It's powered by in this case, a 12-volt lithium battery, and this would be the battery then that would be used for the propulsion system motors. So it fits into the bottom of the small waterproof housing. We have 3 waterproof connectors coming out. These connectors then are on pigtails with O-ring seals in them, so in the event that the motor or the LCD panel goes out, it's simply a matter of replacement of the cable. Now, the first cable that I have coming out through a water pin connector is to a brushless motor that's putting out about 1,000 watts. The second connector is coming up to my speed controller. This is simply a potentiometer. My third control output comes to the right through a 4-pin waterproof connector into my LCD data display module. So the concept behind it is we turn the speed control on. That sends a signal to the processing electronics, supplying battery voltage through the sensors to the motor. While it's doing it, the data processing electronics picks up the signal and then puts it into the LCD panel. Now, my LCD panel has 4 parameters onto it. I will zoom in, and the parameters that you see displayed now are the amps in the upper left, the pack voltage, which is 12.44, the RPM, and the milliamp hours consumed to the battery. So it's like a battery level gauge connected with it. So what I will do is I will turn the dial. You can hear my motor going on and my LCD panel changing. So let me move in close. A little bit of glare on that. Our RPM is about 6,700. We're pulling 2.4 amps, no load. Our pack voltage is 12.34, and we've so far used 35 milliamp hours, now 36, now 37. Now I can increase the speed. Now I'm up to approximately 10,000 RPM. I'm pulling 3.3 amps. The pack voltage remains about 12.33, and right now I'm using 52 milliamp hours. Now what I'll do is I'll slow it back down again and complete that as the first part of the test. Just for demonstration purposes and give you an idea of relative size, I've temporarily secured the LCD data display inside a standard AGA full-face communications mask. So you're looking at the data display unit in the mask, and what I'll do is I'll control the speed of the motor to again give you a relative idea. So turning the motor on, I have the motor setting on a foam pad so it isn't quite as loud. You can see now I'm pulling about 7,000 or 8,000 RPM at 2.7 amps. My pack voltage remains about 12.3 volts, and my milliamp hours that I've drawn are 94 total. You can see the response on this thing, cutting down, turning it up, turning it down, turning it up. So the display then gives me very accurate information on all the motor performance parameters, as well as, importantly, the battery pack voltage remaining. This then represents the entire completed system. The battery is contained in the underwater housing, the 3 connectors coming out, one to the motor, one to the speed controller, and then the third one to the data display that would be mounted on some type of mask. Now for the wireless test with the same technology. In this, the second part of the demonstration, I'm going to show the ability to transmit wirelessly from our data interface box to a small self-contained receiver that would be mounted on the diver's mask or somewhere on the proximity of this faceplate. Now this unit is a complete standalone receive data unit. It is machined from a piece of plexiglass. It has a front onto it, an O-ring seal, and inside you can see the electronics. The wireless and the data recording system, that's just powered by a small 2-cell lithium battery that will power the unit for approximately 8 hours. I've powered the unit up, so in this case, if we move in, I'll angle this slightly so you can see it hopefully a little bit better. Hard to see. There it is. There's a lot of dust on this, so what I'll do is I'll take the front cover off. But again, it's completely wireless. There are no wires from the system, no magic. I can draw my hand in here. So what we're looking at are a couple of parameters. In the upper left, it's the amp draw. To the right top is RPM, battery pack, battery meter, tank meter. It's down to the lower left. And now I've included one called temperature. People may want to know the water temperature. So what I have is, I have an ice cube. So what I'll do is I'll put that at my thermistor on 3, 2, 1. So now it is in contacting with it. Now you can see the temperature dropping as a result then of the unit being close to the ice, and I'll pull it off, warm it up with my hands. You can see it's now up to geez, about 85. And then putting the thermistor back onto the top of the ice, it slows down relatively quickly. Now what I'm going to do is the same test I did before. I'll use this little speed controller. You won't hear too much vibration because the motor is on this little foam pad. But you can see on this wireless display how the values change. So what I'll do is I'll turn on my speed controller. My RPM now is up to approximately 5,000. My no-load draw is 1.1. I have pulled 43 milliamp hours out of the battery pack, and my temperature is cool. It's near the ice, but not on the ice. So as I increase the speed on this thing, you can see the RPM varying. The response is almost instant. Now again, I've displayed 4 parameters, but I can scroll the screen and I can put up to 4 different windows, which will sequence onto here if I want. These can be placed in any position on the screen, so this would make it both ideal for testing as well as for operation. Now the in-water range from the preliminary tests that I've done is several meters. So that would be more than sufficient to get from the tank up into the wireless data display of the diver. So a very simple unit. Machine case, electronics, dual lithium battery, waterproof seal in the top, but I've added one more thing. To turn the unit on and off, what we do is we have a magnetic capability. So all I need to do is put a little magnet, which could be on my ring or my index finger, and it would turn it off. Now let me give you an idea how that works. I've got a little neodymium magnet here, so what I'll do is I'll come in proximity to this unit, and if I come in close, pick the right place, there it is, it's muted, turns on, I can hold it there and it will actually cycle the unit off completely. On again, off again. So it's very easy to control the on-off position just by this little magnet switch. So I've turned the power completely off of the unit. Again, removing the case. If I want to turn the power back on again, all I have to do is to take my magnet and move it into the correct position. And there it is. It's scrolling on the screen. My data should be coming up, and with my data coming up, turning my controller, and lo and behold, we have a complete wireless data acquisition system, all in a simple self-contained package with its own lithium battery. End of test from Lake Forest, California.